Hey everyone, welcome to AP Stats virtual class. Today is our very first class, and we're gonna go ahead and get started with Unit 7. So in this Google post, I have already uploaded the Unit 7 notes guide that you may print out or just write along in a piece of paper if you don't have a printer. I've uploaded the pacing guide in the previous post as well as the weekly schedule. So we're going to go ahead and go through this video. I'm going to be switching between the iPad screen, which shows your notes, as well as the calculator or the demonstration that we're going to do at the end of class. So let's go ahead and get started. So we're going to start with lesson 1, and lesson 1 is a review of binomial distribution and using that idea to understand why is it that we can do sampling distributions and do sampling proportions for some types of problems. So as you know, this unit is called hypothesis test on proportions. It's very similar to what we already did last unit. However, this time we're working on proportions. So proportions means that it's the amount of time that something appears in a set experiment. So for example, if I do 100 trials, right, how many of those trials will appear tails on a coin, right? Or if I'm looking at a bag of M&Ms, right, and I take 10 M&Ms out, what proportion of those M&Ms, what percentage of those M&Ms is going to be blue? So essentially that's what we're doing. And when we are doing proportions tests, we're actually looking at the z-score of a problem. Okay, so last unit we were looking at t-scores. This time we're doing z-scores for proportions. So let's go ahead and get started. We're going to go back to our notes. So a little bit of review. A popular candy company makes color-coded chocolates. It states that 20% of its candies are brown and that all other colors are equally distributed. A consumer is looking at a random sample of 10 candies. So random sample of 10 candies, this means that n equals 10. Okay. Part A says, what is the probability that more than 4 of those candies are brown? If this event happens, would you be surprised? Justify your answer. So the key word here, saying more than 4, means that we should do a binomial distribution. Okay, so this is a binomial distribution. So as a reminder, a binomial distribution is this equation. P of big X equal little x is n, choose k, times p, so the probability of success to the power of k, times 1 minus p to the power of n minus k. So in this case, we're looking at n equals 10 because we have 10 M&Ms that we're picking, and our probability is 0.2. Since the probability of getting a brown M&M is 20%. Now, the problem says, what is the probability that more than 4? So more than 4 means we're looking at probability of getting 5, 6, 7, 8, or 9. So that means probability of X is greater than or equal to 5. So that would mean we're doing 5, we're doing 10 choose 5 times 0.2 to the power of 5 times 0.8 to the power of 5 plus 10 choose 6 times 0.2 to the power of 6 times times 0.8 to the power of 4 plus ... all the way up until 10. Now, this takes too long. I'm going to do this in a calculator. So, if we look into a calculator, sorry about that. If we look in a calculator, we know that a binomial CDF goes from 0 to whatever our upper bound is. So in this case, we're going to do a binomial CDF of 10, 0.2, and 4. So I'm going to go ahead and show you what that looks like on a calculator. So we're here on our calculator screen. You're going to go ahead and hit second and distribution and go down until you see binomial CDF. Okay. In this case, we have 10 trials with a probability of 0.2. Our x value, which is our upper bound, is going to be 4. Because remember, we want to subtract out the probabilities from 0 to 4. And then hit paste. This means that we have a probability of 0.96. So if we're back on our iPads, on the iPad, right, in our notes, we're going to do 1 minus 0.967, which gives us a probability of approximately 0.03. So the probability of getting 5 or more candies that are brown has a 3% chance. This percentage is really low. This is low. So if we get 5 or more brown M&Ms, I'd be surprised. Okay, I would be very surprised. So then I'm going to ask myself, we have this random sample of 10. How many candies would we expect to be brown? And what is the associated standard deviation of the distribution of 10 candies? Show the work that leads to your answer. So since we are using proportions and saying 20% are brown, we have to use an equation that's different from last unit to find the expected value and standard deviation. So the expected value is going to be n times p, where n is our sample size. So in this case, our sample size is 10 times 0.2. This means that we expect, out of the 10 candies, we expect 2 of them to be brown. So we expect 2 out of 10 to be brown. Okay. Now our standard deviation is going to be the square root of n times p times 1 minus p. So in this case, it's going to be 10 times 0.2 times 0.8, and take the square root of that, and we get 1.26. Okay. So, part C. On the provided graph below, sketch a graph of the probability distribution of the number of brown candies in a sample size of 10. Then describe characteristics of the distribution. So again, we know that this is a binomial distribution, right? So we can use binomial PDF to find the probability of each x value, right? So we're back on our calculator screen. We're going to do vars. We're going to do second and vars. Go down to binomial PDF now. So this finds it at the precise number. Our trials is still 10. 0.2 for the probability. And this time we're going to do it for every single x value. So x value of 0. So there's a 10% chance, 10.7% chance that none of the brown M&Ms will be brown. Now, we want to figure out what's the probability that one of those M&Ms is brown. So I'm going to go back up. I'm going to hit 1. And I have a 26% chance of having a brown M&M. So I'm going to go ahead and draw this into the graph. So I've done this all for you. So at 0, it's 10%. For 1, it's 26%. And let me do this in a different color so that y'all can see this better. So 10 percent, 25% or 26% for 1. For 2, it's at 30, or roughly 30. For 3, it's at 20. For 4, it's just under 10. For 5, it's is 3. We just figured that out. And then as we keep going down, it just gets less and less and less. Okay. And that makes sense, right? The probability of getting 10 brown M&Ms in one trial is very rare. It's very low. Okay. So we're going to go ahead and do a quick simulation activity. Assume that we want to find 100 random samples size 10, count the number of brown M&Ms for each sample, and then plot the data on the number line. How could we conduct the simulation with 10 M&Ms, 2 brown and 8 not brown? How could we conduct a simulation with 100 M&Ms? How many would need to be brown, and how many would need to not be brown? Instead of handling candies and drawing samples over and over again, we're going to use technology to create the random sample for us. So I've gone ahead and typed up the steps for the 2 different calculators. I'm going to show you what to do for a binomial, for a TI-84. And if you have a TI Inspire, go ahead and just follow along with your notes. So what you're going to do is you're going to go ahead and hit Stat and edit your list. You're going to go up to L1, clear that, and click Enter to make sure there's nothing there. Then go back to L1. You're going to click Math, scroll over to Probability, and you're going to do Rand Bin, and click that. N represents our sample size. So remember, each time we're doing a sample, we're going to pick 10 M&Ms. And of those 10 M&Ms, 20% is going to be brown. And we're going to do this for 100 trials. Okay, it's going to look like this, where it has L1 equals Rand Bin. And you're going to hit Enter. And then give this some time. What you see now is a list of trials for each of the sample size of 10. So in this first trial, in a sample size of 10, 0 of them were brown. In the second one, in the second trial, out of the 10 M&Ms, 2 of them were brown. So what are we going to do now? We're going to go ahead and create a histogram. So we're going to go second, stat plot, and then hit Enter for the first plot. You're going to make sure that we're on the histogram, which is this one right here, and that this one says L1. Once you have done that, you're going to go to Window. Make sure that Xmin is 0, Xmax is 10, and we're going in interval of 1. So our bin width is going to be 1. Then you're going to hit Zoom. You're going to hit go down to Stat Plot. And this is going to graph your plot. So this first one is saying from 0 to 1, how many times do we have 0 M&Ms that were brown? This one is for 1, 2, 3, 4, 5, 6, 7, 8. So if we wanted to zoom out a bit to make sure that we see all 10, and this is what we get, which doesn't look right, so let's go ahead and fix this. So again, 0, 10, and then X scale is 1, and it just hit graph, and that's going to do it for you. So we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 is off the screen. So let's do this again and fix it so that it's 11, so we can see everything. So we got 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so again, this means that 0 M&Ms were brown, 1 M&M was brown, 2 M&M was brown, 3, 4, 5, 6. Now, if you look at this, right, this looks very similar to what we drew on our iPad or on our notes, right? It looks very similar to that. Now, how do you want to figure out this frequency? Well, you can trace it, right? This says that 18 out of the 100 trials had 0 M&Ms. So 18 out of 100 had 0 M&Ms. So that means 18% of the trials had 0 brown M&Ms. For 31 out of the 100 trials had 1 brown M&M. So 31%. All right, this is very similar to what we're doing. Very similar to the graph that we drew earlier when we did a binomial distribution. So just remember that these percentages will be different, and the graph is looking different because this is a random sampling. Okay. So we're going to go back to our iPad, right? And it says for number 10, calculate the mean and standard deviation using one var stat for the M&Ms. So we're going to go ahead and go to stat. We're going to go to calc and one var stat. We'll make sure that it says list 1, frequency is blank, and then calculate. X bar shows 1.83, which means that we are expecting 1.83, or the average number of brown M&Ms for this case is 1.83. So mean equals 1.83, and standard deviation is equal to 1.37. So remember, this is a sample, so we need to use S sub X, okay? So this right here is very close to our equations. All right, very close to our equations. Let's move forward. Sampling distributions of sample proportions. When considering the sampling distribution of sample proportions, we are looking at repeated random samples of size n. So repeated random samples of size n. So in this case, we did 100 trials of size 10. So each time we took a trial, there was 10 M&Ms. Here's the second trial. There's also 10 M&Ms. So this is trial number 1, trial number 2. And plotting the number of success over n to make our sample proportion. So our success is what we want. Right. So if we go back to the example, what did we define as success? Next, our sampling distribution of sample proportions will have a center. So this is our mean, right? Our mean is given by mu of p hat. So this is p hat. You read this as p hat is equal to n times p over n, which is equal to p. So mu of p hat equals p naught. Okay, and p naught is the proportion that we are claiming in the problem. So for example, in the M&M problem, p naught is 20%. Our sampling distribution of our sample proportions will have a spread. So the spread is standard deviation of sigma p hat is equal to, and it simplifies to this, p times 1 minus p over n. Okay. All right. So both of these equations are found on your formula chart. You don't have to memorize it since it is on your chart. You can use the normal model to calculate probabilities for the sample distribution for sample proportions when the expected number of successes calculated by n times p and the expected number of failures or not successes calculated by n times 1 minus p are both greater than or equal to 10. So this only applies, so you can only say that something is normal if both of these conditions are met. Okay, if one of the condition is met but not the other, you have to use a binomial distribution now. So why use a normal model and sampling distributions of sample proportions to approximate binomial? Because back in the day, they would have had to calculate each and every binomial piece from 201 to 500 by hand. Would you rather do all these calculations or convert the distribution to something you could use the z-chart to calculate? If so, do these calculations. You start on that now by hand, and we'll see you after graduation. Check for understanding. So in our review and simulation problems, we used the known proportion of brown M&Ms at 20% to calculate our probability distribution. What sample size would you need to take to ensure that our sampling distribution for the sample proportion of brown M&Ms follow a normal distribution? So a normal distribution occurs when n times p is greater than 10 and n times 1 minus p is greater than 10. So let's start with the first one. N times p is greater than 10. We're trying to solve for n. We know p. So n times 0.2 is greater than 10, which means n equals 10 divided by 0.2, which is 50. Okay. Now if we do the second one, we know that n times 1 minus 0.2 must be greater than 10. So n is greater than 10 divided by 0.8, which is 12.5. In this case, then n must be 50. Okay, n must be 50. The reason why n must be greater than 50 is because this is the biggest size. We always take the bigger sample size. Okay. If we take the bigger sample size, we always satisfy the other one. Okay. Let's move on and do a model problem. We'll go through some practice problems. And as you're doing the practice problems, I'm going to ask you to do some of the check for understanding and submit your answer so I know and can check with y'all. So model problem. This is from the 2002 multiple choice problem. So suppose that the public opinion in a large city is 65% in favor of increasing taxes to support the public school systems, and 35% is against such an increase. If the random sample of 500 people from this city are interviewed, what are the approximate probability that more than 200 of these people will be against increasing taxes? So in this case, we're looking at people that are against increasing taxes. That means our P naught, what we're claiming, is going to be 35%. Okay. Our P hat is going to be 200 over 500. Okay. And we're going to figure that out. This is going to be 0.4. Okay. So first, using the binomial model, we want P of x greater than 200, which means that we're doing 500 choose 201 times 0.35 to the power of 201 times 0.65 to the power of 299 plus all the way up until 500 choose 500 times 0.35 times 500 times 0.65 times to the power of 0. That's too much work. This is going to take us way too long to do, even in our calculators. So what do we have to do? We're going to use a sampling distribution of sample proportions. So first, we're going to check, is this normal? Okay, so we got n times p must be greater than 10, which means that we have 0.35. We have 500 times 0.35, which is equal to 175. Then we check the other conditions. N times 1 minus p is greater than 10. So 500 times 1 minus 0.35, which gives me 325. This are both greater than 10. Notice that these two add up to 500. That's how you know that you're right. Next, we know that mu of p hat is equal to p, which is 0.35, and sigma of p hat is equal to the square root of 0.35 times 0.65 divided by 500, and this is 0.02. Okay, so how do I do this? Well, we're going to use a z-score. So we're going to use z equals p hat minus p naught divided by standard deviation of p hat. So this is 0.4 minus 0.35 divided by 0.02. I'm going to go ahead and put this into a calculator. So this is what we're going to do. So on our calculator screen, we're going to go to stat, go to test, and you're going to go down to one prop z-test. So this is one proportion z-test. Our p hat is 0.4. Sorry, our p naught is 0.35. Our x is 200. And our n is 500. The problem says, what is the approximate probability that more than 200 of these people will be against increasing taxes? So we want to be more than p naught. Throw this into your calculator, and you get z equals 2.34 with p equals 0.009. You're going to go ahead and draw out your curve. So z is at the center is our p naught, and we're going to shade to the right. Okay. So if this was a multiple choice question, we know that we are not using a binomial because these two binomials are at a precise value and it's not at a combination. So we want it at 200 or more. We know that p naught is going to be 0.35. So this is wrong. And we know that the inside probability is going to be p naught times 1 minus p naught over n. So this is wrong. So the answer is E. Okay, we're going to go ahead and move on. So how do we tell the difference between a binomial distribution or a sampling distribution of sample proportion? So, Julie generates a sample of 20 random integers between 0 and 9 inclusive. She records a number of 6s in a sample, and she repeats this process 99 more times and records a number of 6s in each sample. What is the distribution? What kind of distribution has she simulated? Well, we know that n equals 20, so all the ones where it says n equals 100, we can cross those out. So remember, n is the sample size, not how many times we do the experiment. We know that p is equal to 1 over 10, because in total we have 10 numbers, and only one of those is 6, so p equals 0.1. So we can go ahead and cross out A, and cross out E, and we're left with C. This is also a binomial distribution because there's either a success or not a success, right? Sampling distribution of sample proportions would have to say that it's normal, but we don't know. This is definitely not normal because our sample size is not greater than, if we do the n times p, this is not greater than or equal to 10. Next. According to the National Collegiate Athletes Association, NCAA, athletes at major college and universities graduate on the whole at virtually the same rate as other students. The survey involved students who had entered college before the NCAA Proposition 48 took effect in 1985, stated that all athletes must maintain at least a 2.0 GPA on a 4.0 scale. But before Proposition 48 took effect, the average graduation rate for athletes was 51%. So this is what they're claiming. This is P naught. Suppose that the new pool of 500 randomly selected athletes at a major college was collected and the number graduating was 268. Describe the sampling distribution for the sample size of 500 students, or 500 athletes. So we know that 268 over 500 equals P hat. Okay, so we know that it's not A and B because we're not looking at n is greater than 30. That's only if we're doing a sample mean. Since we're doing a sample proportion, we need to look at size 10. Now, I know that the answer is going to be C because mu of P hat equals 51. So remember, P naught equals mu of P hat. And we know that the sampling or the standard deviation is calculated by using this equation. Okay. We're going to go ahead and do the practice problems. What I ask you to do is, as you're doing the practice problem, you're going to pause this video, submit your answers for your check for understanding, and see if you're correct, and watch the video. So go ahead, you're going to click your answers now for practice problem number 1. Practice problem number 1 says, a recently published study reported that 63% of the nation's students have some type of structured homework study time. A local faculty surveyed 83 students and found that 43 students reported on having a structured homework time what would the correct z-score of the situation? So we know that 63% is our p naught, and we know that p hat is equal to 43 over 83. And if you calculate this is about 0.52%. So I know that z is equal to p hat minus p naught all over the standard deviation, which is equal to the square root of p hat times 1 minus p hat. Sorry, no. It's p naught. Let's go back and look at our notes since I'm not sure. This is going to be p naught. Yes, it's going to be p naught. So we're doing p naught minus times 1 minus p naught over n. So in this case, p naught times 1 minus p naught over n. So in this case, p hat is 0.52 minus 0.63 all over the square root of 0.63 times 0.37 over 83. So the correct answer here is A. We're almost done. Number 2. A professor claims that 95% of his students pass his class. However, this last semester, only 140 of his class out of the 150 students passed this class. Describe the sampling distribution. So we know that p hat is going to be 95%. And I know that p naught is 95%. P hat is equal to 140 over 150, which is 93%. So we're going to first see, is this normal? So n times p is equal to 150 times 0.95, which is 142.5. N times 1 minus p equals 150 times 0.05, which is 7.5. And if I were to check this, so this is not equal to, not greater than or equal to 10. So we would say it's not normal. But in our case, we're going to say it's normal enough. Okay. What is the probability of obtaining the sample proportion of something as rare? Should the administration at the university be alarmed by this passing percentage? Why or why not? So z equals p hat minus p naught over sigma p hat. So that's going to be 0.93 minus 0.95 divided by the square root of 0.95 times 0.05 all over 150. This gives me a z-score of negative 0.93. And since we want it to be something as rare, this means that we're doing p of z is less than or equal to negative 0.93. So in this case, we get p equals 17%. So I'm not surprised. Right? If we're using the 5% rule, I'm not surprised by this. Okay. That's all for today. As you notice at the bottom of your notes, you see that there is a simulation. If you want to do the simulation, you can. However, I'm not requiring for you to do so. Let me know if you have any questions. Make sure that you pause and watch the video again at times that you are unsure of. And if you have any questions, make sure that you hop into office hours. I posted a link for you all to vote on when's the best time to do office hours. Please let me know, as I can create an office hour that works better for you all. There's also the form. If you want to request office hours, make sure that you fill out that form and we can schedule a time to meet. I'll see y'all in the next class.